At this point, we've built 12 different projects throughout this bootcamp. We've primarily been using the local environment for development, but now we're ready to move an application to production. If you have a software engineering background, you're probably familiar with the large amount of work to move from a local development or QA environment to a full-scale production environment. Thorough testing, continuous integration, continuous deployment processes, managing edge cases, monitoring your applications, and adding proper security measures to prevent issues are all different action items a software engineering team usually does in getting ready for deployment. Deploying an application to production within the blockchain space is very similar. You have all the same steps, but you have some additional actions that need to be taken care of to be successful. The first of these is getting your smart contract properly audited. Given the large amount of funds stored within smart contracts today, it's critically important to be free of any exploits. While you cannot ever be 100% certain that your smart contract is free of bugs or exploits, any additional work you can do to proactively avoid hacks is advisable. The second step is making sure any authority key that you may own, such as a smart contract upgrade key, token authority, etc., is properly behind a multisig. Multisig, or multi-signature, can make an authority require signatures from more than one party. If the parties are sufficiently separated, they have to come into agreement to update a smart contract, mint tokens on the blockchain, or access funds in a treasury. The third step you need to take is obtaining proper infrastructure to make the user experience on your application as good as possible. Solana is write optimized, meaning that the transactions sent to the network will be fast, but reading the data may be a bit slower. Infrastructure could be running your own RPC or paying one of the RPC providers, using an indexer to provide the most up-to-date data for your accounts, or even running your own validator to verify transactions were successful. Just as a note, you may not need any of these depending on your application, but some of these can help you provide a better experience to your users. The last step to take is to make your application easily composable and viewable by other developers or users. This includes publishing your IDL, verifying your smart contract on explorers, or potentially creating SDKs that make your smart contract easy to interact with on other platforms. We'll be doing some of these steps and more on the voting application that we built earlier in the bootcamp. Let's get started. So we're going to take an application to production. We're going to take that voting application that we did early on in the bootcamp and do all the work that needs to make it fully productionized and ready to deploy to mainnet on Solana. So the things we're going to do is first we're going to download the voting application. We're going to look at it and see what the UI looks like today. Then we're going to add something called prioritization fees, and we'll get into this a little bit in a moment. We're going to calculate those priority fees correctly, and we're going to grab the specific tools needed to do that. Following that, we're going to add some fuzz tests to our application, and we're going to deploy our application to DevNet. We're going to grab an RPC so that we actually are using a real RPC versus public infra. We're going to talk about some security things, and then we're actually going to deploy our application to mainnet, to production. And we're going to showcase all the work needed to be done to do that, and also secure our application on mainnet. So let's get started. All right, so the first thing we're going to do is we're going to go to the Developer Bootcamp 2024, and we're going to clone the repo. Now, you might have already had this repo cloned, so you're welcome to work in that clone. I'm going to just go from scratch so that you don't have to worry about it. So first off, I'm going to go ahead and clone it. So I'm going to clone it in a temp bootcamp repo so I can actually remember where I did it. Git clone repo. I cloned it, and now let's go ahead and open that repo. So I'm going to go over to that folder, temp bootcamp, and we're going to go to project 14, getting to production, and open that repo. So what you'll see right here immediately is you'll have a project that has Anchor, and has a web, and what we're going to have to do is we're going to have to npm install first off. So npm install, make sure we have all the dependencies installed, and in another terminal, we're going to do cd into the Anchor folder. Let me just make this bigger so everybody can see. Cd into the Anchor folder, Anchor build, and so that we're building all our projects. And so once this is built, built, we will come back and we will do the next step. All right, so everything built, and we can go check over here as well. Looks like the npm install worked just fine. And so let's go ahead and open another terminal. So we'll open another terminal and we'll do Solana test validator. This is so that we're running it. I'm actually going to run it with -R just to make sure that everything is a clean slate. We don't have any issues. So let's get this running. And then over here, what we're going to do is we're going to actually do anchor deploy. So we can deploy our specific smart contract to our local validator. So let's go run that. All right, so it ran. You can see that it has a program ID right here. So one thing that we're going to do real quick is in the voting spec, it's going to have a new public key. We're going to just update that voting address to whatever was spat out. There we go. And I'm going to do an anchor keys sync. That way it syncs everywhere else. So look, it found an incorrect program ID declaration in some spots. So we can actually see that it updated everywhere. So if I go to programs, you can see it's now AZ, which is what we put right here, AYZ, and also put it in the anchor toml. Perfect, wonderful. So it added everything, we're good to go. I'm going to do an anchor test, skip local validator. This is so that it will push all the information that I need in order to run my UI in a moment. It'll create our polls. If you remember creating this test early on, it'll create our polls, it'll create our candidates, and it will create a initialized vote for a candidate. So let's go ahead and run that real quick. Perfect, so it ran. I'm going to move over to this one. This one's in the root directory of the project 14. And what we're going to do is we're going to do npm run dev. And this will run our website. And you'll see this is not an actual website that we built in the original project. It's just something we mocked up for this. So let's go look at that website real quick. So I'm going to go over to localhost 3000. And once it loads, we should be able to see our website, which is a voting application. There we go. And what happens is we have a crunchy and smooth peanut butter to vote for. And if I click on it, it'll pop up my wallet that I have connected. I'm using Backpack for this one. And I'm going to send my transaction, and you can see it immediately updates. We can just keep voting for it. Looks great. So our application works, everything's doing well, but there's a few things to keep in mind before we continue. Let's say there's a lot of people running on this. What ends up happening is you might end up having your users pay a little bit more fees to make sure that their transactions get submitted to the network. So let's look at this in practice. Let's say we have some hot application. We're going to call this application market. We have our voting app. All right, so we have these two applications, right? So let's say there's 1,000 users on this one. And maybe there's only tens of users here. So there's only 10 users. We're still getting started. We just deployed to production. What will happen is this account the priority fees for those 1,000 users might go up a little bit so that people can get their transactions included into this account. While our app, while we only have 10 users, we don't really need priority fees. Now let's say if there's, I don't know, 100 of these hot application markets with hundreds of thousands of users working on Solana. What you end up having is every one of those accounts might have an isolated market where they're paying a little bit more priority fees to access that market, but ours overall will not go up that much. So what does this look like in practice? Let's go over to look at the current fees or prioritization fees on Solana today. So we're going to go into this website called Solana Compass. They track a bunch of different information like the TPS, but what we care about is this live fee data. So you can see here on the average priority fee, we'll put it in Sol so that we can see it in Sol, is 0.0008-ish Sol every minute or so. That's the average. If you remember from my Scala draw, what we were saying is that if this one has a lot, only these users may pay more to access this market, versus these they shouldn't have to pay too much more to access our voting app because they're isolated. And what we see this in practice is the median fee is still very low because all those not hot markets or not hot accounts are not very active, but the average fee might be higher because of the other markets or the accounts that have a large amount of users end up getting more people working on them. We can see this here with like the max priority fees, and let's put them in .sol, is like 0.1, 0.2. So there are people paying a ton of money, but the minimum fee to get included is 5,001 LAN ports. And so you might see that like, hey, why is it 5,001? What ends up happening is on mainnet is you have a bunch of people using mainnet. So you have the fee or your base fee plus your prioritization additional fee, and that'll get you into mainnet. So if you just pay even one LAN port today at the time of recording, you have a good chance of getting in if it's a low market or account, low used account. So what we end up having is the prioritization fee, or the prioritization equals your CU cost, your LAN ports, micro LAN ports per CU cost, per CU. All right, so there's another word here, CU. So what is that? Let's go look at our transaction. So I'm gonna run this transaction real quick, and we're gonna go look at on the Explorer. You can see on the Explorer, our compute cost for this transaction was 7,562. So what that means is this is the units of compute that it took to execute on the cluster. And if we can get that lower, our overall fee for prioritization to receive higher prioritization will end up being less because it'll take less micro LAN ports per CU to get a higher prioritization on the cluster. All right, so we've talked about prioritization fees. Let's actually build it into our application. So we're going to go over to Visual Studio, and we're going to go into Components, and we'll go to Voting, and we're going to go into the Data Access. So what this is everything that is being run whenever you click those buttons. So you can see here, this is the Use Voting Program candidate account, and we can see here that there's a vote. So this is what happens when that vote button is pressed. So I'm going to go ahead and make some changes to this. We're going to make this an async method. And let's see, we need that there. And we're going to need it down here as well. Actually, no, right here. And then comma, and remove this. All right, so this is so that we have the execution logic separated. And we're going to have to do something that you've probably done in the other bootcamp, the other parts of this bootcamp. And we're going to have to break up this .rpc into an instruction, add the instructions in order to do compute. So let's go ahead and do that. I'm going to first look at Solana. We're going to go to solana.com docs, go to cookbook. And if you go to I believe it's the transaction one. Yes. Add prioritization fees. So how to add prioritization fees to a transaction. We can see right here, there's two different instructions that we'll need. So we're going to go ahead and grab those. It's going to ask for compute budget program. So we're going to go add that as well. And so these will return an instruction for us to add to a transaction. All right, so first off, modify compute units. We know from our transaction, it took about 7562. However, this might not be the max. I'm not entirely sure, so we're going to just double check on another transaction. So 7562, let's see, also 7562. For this specific smart contract, we know that the max may be 7562 CU. However, this may not always be your max CU. There are some things that cost more compute, such as creating a PDA that has a different bump. The higher bump may take more CU than if your program had a lower bump. So we have these units. I'm going to go ahead and add a little bit of room for it. I would recommend adding a little bit of headroom so that your users do not run into unexpected errors. but you can tighten this headroom by doing a bunch of tests later in order to figure out what are the max compute units that your smart contract might use. So we're going to add that. Right now, we're going to set the desired priority fee as 1. I'm going to change this into an instruction so that we can get the instruction. So const vote equals program methods vote candidate B1. And then we're going to have to create our actual transaction. So const transaction equals new transaction from web3.js. And you can see it already knows what I want to do. Let's see, it doesn't know how to add vote, transaction. Okay, so it wants us to, this is a promise. So we just have to make sure we await it. There we go. I'm just going to do a little bit of cleanup on the formatting here. And so what this is doing is it's adding all of our instructions to add priority fees to our transaction for our vote. All right, so final thing is we're going to have to add some information in the transaction for it to be block hash. We're going to need a transaction block hash context. It will be fee pair, block hash, and last valid block height. So let's just go ahead and list all those out. Fee pair, block hash, last valid block height. All right, so what do we need to do that? We need to actually go grab that information. So let's go add a new thing here. We're going to add 2 things. We're going to add const connection equals use connection and const wallet and send transaction. These are the 2 things that you need in order to actually send a transaction using our wallet on use wallet. There we go. All right, and then we actually need not the wallet, but the public key so that we can use that as the pair. So our fee pair is going to be that specific public key. So we have that down. Now we need block hash and last valid block height. So we're going to create a new block hash context equals await connection dot get latest block hash and context. And let's just grab that and put in the values that are available. So it's value dot block hash, and the same thing is going to be dot value dot last valid block height. There we go. So we have our transaction. Now we need to just send it. So we're going to do a return await send transaction. This is the thing that we ended up creating earlier. It's going to be transaction, comma, connection, and that is it. And we have a signature. So let's go ahead and check that in practice. So let's go to our voting DApp. We're going to refresh it because it errored out at some point whenever we were doing it. Okay, so it looks like we're just missing a comma somewhere. Okay, so we have this. Oh, we have an extra because I added an extra earlier. There we go. Refresh. Boom. We have our votes. All right, so let's do a vote. I'm going to have to log back in to my approve. And let's look at the error. What was the error that we got? Let's see what error we got from here. I have to vote again just to see what the error is. Oh, transaction sent. So it looks like it was just some issue that we ran into. That's fine. So let's close that and do it one more time just to make sure. Failed to vote for candidate. Transaction sent. All right, so let's go look at that transaction. And we can see here, it had 7412 out of 7,700 compute units. It added the vote, and look at it. Actually, there's more compute as well. This is because the compute budget instruction actually takes a little bit more. And we can see here there's 1 instruction, 2 instruction, 3 instructions. So those first 2 are our instructions that we added. We added 0.00001 LAMP ports per compute unit. And you can see here the fee is that 5,001 SOL. So we've added some additional additional prioritization fees in order to prioritize our transaction on the cluster. Now, one thing is to note is that this micro land ports equals 1 is kind of a dumb value to give there. It's just always adding 1. What if there's a very high value, or say our voting app goes from 10 users to 100,000 users? Suddenly those users might end up having to pay a higher priority fee in order to prioritize their transactions for this specific voting app account. So let's think of how to do that. So if you go over to the RPC methods on the solana.com/docs/RPC and go to get recent prioritization fees RPC method. So this method will actually allow you to get the recent prioritization fees to check what are the fees recently and then make a smart choice on what I should do additionally. So we're going to go and do that. So const recent priority fees equals await connection dot get recent prioritization fees. And then what this ends up giving you is it will be a recent prioritization fees list, and you'll have to pull the right information out in order to figure out what is the current recent priority fees. All right, so let's get the minimum fee in order to get on the cluster. So this will be just a min dot recent priority fees dot map fee, not fee calculator, but fee prioritization fee. Boom. So this gets our minimum fee. And instead of just putting 1, I'm going to put our minimum fee right there. So this minimum fee is just going to be a number. It's going to be a very small number. I want to make sure that this minimum fee we might be paying a little bit more than minimum fee. So we're just going to add 1 to that. And let's go ahead and check it out on our voting app. So we click vote. It'll pop up our wallet. It'll vote for our transaction. We can see transaction sent. And we can see it was still 5,001. And this is because there's nothing happening on my local cluster. So it added only one more land port to my overall fee in order to get it prioritized. That's fine. But however, this will increase if the prioritization fee is higher. Another thing to note is that this is more looking at like global fees. If you want to actually use the real priority fees, you're going to have to add a config, which gives the locked writable accounts. So this is something you'd have to do a little bit more of. So if we go into here and let's go look at that transaction again, we can see here that there's some writable accounts. This one's going to be the candidate account. So if you go to the candidate account, you can see here, what was a 9FD? Yep, that's the candidate account right there. That's what gets updated whenever you vote more. So what we end up having to do is we actually have to give the public key list of the public keys that we plan on doing. And it looks like I probably, let's see, config, and then this is going to be, let's look at what the config, okay, so locked writable accounts. There we go. So this will do the same thing. So if I just pull out and then go over here and run, it'll probably still do 5001. So let's run it. You can tell I really like smooth peanut butter, not crunchy. 5001. And what it ended up doing is it's checking for that specific public key. So we can actually look at that in, say, the network tab. So let's run it one more time. Right here, the payload was, this is the send transaction. Where is it? Get latest block hash. There it is. So get recent priority fees for that specific thing. And the recent priority fees, we can see that there's going to be a whole bunch and it's 0 because there's no additional cost. So you can do either or. This is just the start. This is only to get you started. There's a lot more that you can do to kind of model recent priority fees. There's also some RPC services out there that model them for you and give you an API that allows you to just call that API specifically and get you a better modeled recent priority fee that might guarantee or better guarantee your inclusion on the cluster for all your users. It's very smart to do that. So there's some work that you'll probably be doing in this regard to make sure that this is the best possible fee that you add to your new smart contract, or sorry, your transactions for your users. You're going to have to play around with it. But this is a basic way of doing it. Just take the minimum fee that was required to get on the cluster and add just a little bit potentially on top of it. All right, so the next thing that we want to do is, if you've noticed throughout this whole thing, what we've been doing is we're actually using the RPC that's provided to you instead of using our own RPC for all these different calls. So even if you look at our call right here, we did an RPC call for get recent prioritization fees. We did a RPC call for get latest block hash. This right here is a send transaction prior RPC call. So there's a bunch of RPC calls. Now this works for local, right? Because we're running our local test validator over here, right here. This works for local, but moving up to different environments, say we move to DevNet or even later mainnet, which we're going to do in this bootcamp, we need to go get an RPC provisioned for us. Now there's a number of different places you can get RPCs. If you go to solana.com/RPC, you'll have a page that tells you a bunch of information about what you should do for RPC services. However, it also gives you some different RPC services to go out and get a private service. So this is going to be part of your leveling up system. You've done a bunch of work on local. If you want to get on DevNet or even before mainnet, you must provision some RPC of yourself. You cannot run on the public infra. The rate limits are too high and will kill your application for users. So you have to get some RPC from this list. So what we're going to do is just pick one of these RPCs that you're familiar with on this list and go ahead and grab it. So I'm going to go ahead and grab an RPC off screen, and we'll be back in a moment. All right, so I've grabbed an RPC for DevNet, and the thing that we're going to have to do is we're going to have to actually connect to it. So I'm going to go over here, and we're going to change to DevNet. All right, so one thing you can do quickly is if you do Solana config get, you can see that everything is set to localhost now. Now we need to update to Solana config with the RPC. Now, if you want to, it's okay to use DevNet public RPC. So we're going to do that first. So let's go Solana config set-ud. You can see it now is updated to the public infra for Solana DevNet. And we're going to clear that. And now let's go ahead and push this to DevNet. All right, so I'm going to go over to here. Right here, and we're going to clear it, and I'm going to do an anchor deploy. So this will now deploy to DevNet. All right, so it looks like deploying. It tried to also deploy to local again. So let's just make sure Solana config get. It is set to DevNet. So let's go update our anchor toml to deploy to DevNet. Here we go. So we're going to change this to, I believe it's DevNet, and make sure that, okay, so cluster is also DevNet. There we go. So everything is now set up. So let us deploy to DevNet. We'll do anchor deploy. You can see now it's doing deploying cluster api.devnet.solana.com, and it's deploying. And we have now a smart contract ID. Let's go look at it on DevNet. So I'm going to let's close up some of these windows. We're going to go here. We're going to switch to DevNet. We're going to type in that specific smart contract, and there we go. We have now officially deployed something to DevNet. Now, you might run into some issues with like, hey, you don't have enough Sol. If you need Sol or DevNet Sol, you need to go to faucet.solana.com. You take in your wallet, so you can find that by doing Solana address. So take that wallet, you put it right here, and we probably only need like 5. So we put it at 5 and confirm the airdrop. It'll ask you to do some CAPTCHA, and it should give you an airdrop. There you go. And if you want to get even more solo, you need more solo, go ahead and connect your GitHub, and this will give you a higher airdrop limit overall. So we have deployed to DevNet. We have our smart contract on DevNet. Now I'm going to give a few notes on DevNet. So we have our deployed to DevNet, but we don't want to make this our main area of development. We want to make sure that we're focusing on building on local and using DevNet as more of like a testing environment, making sure everything works. Like for example, what I would want to do is this spec this testing spec might have a DevNet specific one, and I might have a DevNet, a test that runs via CI/CD whenever I'm pushing to GitHub that runs this, and before I move to production. That's something that you just need to make sure that you have. You don't want to build completely on DevNet because DevNet is just a quality assurance environment. It's not our environment to run everything on. If you want to build on Solana, you should be building on local, moving, testing, and checking on DevNet, and then finally pushing to production. So we've made a DevNet. What next? The next thing I'm going to do is we're going to go ahead and make another GitHub repository. We're going to do some things that allows us to check a bunch of information about our smart contract with GitHub Actions. So I'm going to make a repository. We're going to call this the voting app. And I'm just going to create a public repo, and let's go ahead and create the repository. I'd recommend y'all do this as well. And we're going to go ahead and click this button right here for copy, and we're going to push it to our new repo. So let's go ahead, make sure that we're in the right repo or the right folder. This will be the project 14 root directory. And we're going to go ahead and paste all those commands that we just copied and hit enter. And we can go ahead and look at the repo, make sure it actually pushed, and it should have pushed. Yep, developer bootcamp voting app. All right. So we have everything. Now let's make sure we add everything. So GitHub status. It has a whole bunch of uncommitted changes. I'm going to also just make sure git remote, make sure that's set. Yep. All right. So it's set on origin. Perfect. So there's a few things that I want to add real quick is we're going to create a git ignore on our project so that we ignore a bunch of the things that we don't need. So if you click new file, oh, not there, we'll need it over here. New file .git ignore. What you can do is you can actually copy and paste the git ignore from the original project. So let's go to that original project, the bootcamp. Let's go to our git ignore file. Whoops, right here. And I'm going to just grab that git ignore file, boom, copy and paste it, and put it right in there. All right, so this will basically ignore a lot of the extraneous things that should only be deployed on local. So let's just go git status. There we go. We have everything. It's missing. It looks like it's still adding a few things. I think it's .nx. Do we need a .x? Let's go see. Well, yeah, that's just a cache. We don't think we need a .nx. All right. So git status. There we go. So it's now removed most of those things. So we can just do git add all. It'll add it all to staging and git status, git commit initial project. All right, and git push. And so this is now pushing our entire voting application project to our GitHub repo. We're going to need it in our GitHub repo to do some work next via GitHub Actions, verifying our smart contract, and a little bit more extra work. So let's go ahead and wait for this. Okay, so it added everything, it pushed, and if we go check out this repo right here, we can see in my voting app, I have my initial project, everything's here, has that very basic README. So we are ready to do the next step. So first thing what we're going to do is we're going to add a thing called radar. This will be for static analysis. It's going to basically check the security of our project. So we're going to add a folder. Let's go ahead and we're going to go look at the radar thing real quick. So Radar Solana. This is under auditware, Radar. This should be all under the README for the original project. And you can see here, go all the way down. There's some information on it, but we want to just add it to our GitHub actions. So we're going to just grab that Radar action. And we can see here, we can just add it to our repository and it will be good to go. So let's go ahead and add it. So we need to add a folder in the root directory of our project. We're going to call this .github. And inside that also needs a folder called workflows. And we're going to create a file called radar.yaml. All right. So we can go ahead and copy and paste that radar action. So let's go grab it real quick. So radar action. We're going to just copy this right here. So on push, do something. And you can see here, it does an output file. There's an upload. It'll just do path. Our path is actually /anchor. So we're going to pull it from anchor. And we want to see, let's just do no ignore. So ignore should be there we go. It's a temporary thing or a optional thing. And we're just going to add that. So it's got status, git add, git commit, feat, static analysis, git push. And so what static analysis does is it'll check our Git repo. So if we go, let's close that. If we go here, it'll basically be running a scan on our Git repo, our smart contract, to see if there's any vulnerabilities in it. And it's always good to have this. So this is going to be one of the actions that we add to double check, hey, is our Git repo all good? If it is, awesome. We can move to production. If it isn't, let's go fix those different findings that the static analysis scanner found. So I'm going to go ahead and open it right here. And we're going to wait for it to complete. And we're going to go look at its findings. All right, so it's all done. So let's go check out our findings. You can actually just look up here. You can see the results. It says, oh, it actually did find a few things. So missing signer check found at this line, so line 45. Let's go to line 45 of our code and see what it's talking about. librs, line 45. So line 45 is, it has a signer check. And what it's saying is like, hey, there's no signer check to create this account. So we have a few accounts here. We have a candidate account. We have a poll account. So it's like, hey, there needs to be a check to create these accounts. Now for us, we don't actually care because what we're doing is anybody can create these and we're okay with that. If you are making it better or more extensible or, hey, there's only one person can create that account, that's something to consider. So these are like considered low errors. So it's something that you always look at. It says, okay, so we have duplicate mutable accounts found on line 16. Let's go look at that real quick. All right, so on line 16, we have this poll equals mutable account, mutable accounts poll. So what it's saying is this poll, because I made it it's already mutable. It's actually set as mutable down here. Let's see where this is in the initialized poll. So that will have the init right here. So this init actually makes this poll mutable already. So we didn't have to do that. This is just to be careful, like making sure that we don't make something mutable that we don't know about it. It's okay here. And also missing owner check, making sure that it owns, this is probably what, 45, sort of 45. Yeah, for vote, making sure that the person who's updating this account actually owns it. We don't care. Anybody can update this account because anybody can vote. So these are just telling us like, hey, make sure that you are covering all these things because if you're not, you probably have a security vulnerability. All right, so we just spent some time adding a static analysis to our application so that we can check it before we get to production. Now, this is just some preventative measures. There's even more that we can and should do in order to make sure our smart contract is properly secure when we deploy it to production. So one of the things is we should get an audit from some security company to audit us. Radar won't cut it. It will give us a lot of like heads up and save us potentially some headaches, but we should definitely get an audit on our smart contract. If you want to do that, you can just go look up Solana Solana auditors, and you should get some list of auditing companies. What you can do is also you can check what auditors that Solana Labs has used. If you go here, you can see all the different reports. We have Halborn, Neodyme, Koldelsky, OtterSec, Trail of Bits, Zelic. We have a bunch of different auditors auditing the Solana core code base. Now, these might not be the auditor for you, but definitely do your research. Go find an auditor out there. I just gave you a list of names to go check out. There might be more for you out there for your smart contract, but it is an absolute requirement to get to reduction, because you don't want the last thing that you want is an exploit getting deployed and you get some odd $100 million in your smart contract, and that exploit is used to drain all the funds. That's the last thing you want. So definitely get an audit. These audits don't guarantee, but they're a good preventative measure to prevent you from running into an exploit in production. All right, so the next thing we're going to do is we're going to actually deploy our smart contract to mainnet or production. While we won't have anything on the front end deployed to actually interact with it, we will go through the steps to deploy it from our local setup to production. So let's get started. First thing that we're going to have to do is we're going to have to set our URL using the Solana CLI to that specific RPC that we bought on earlier. So let's go ahead and do that. So I'm going to do Solana config set -- URL, and I'm going to go grab it and set mine. I'm not going to showcase mine because anybody can use it, but we'll be back in just a moment. All right. So the way that you can check if you set it correctly, which I just showed you the command, is you can do Solana config get, and this Solana config get will showcase the specific RPC URL that you set your configuration to. All right. Let's go ahead and deploy now. So what you have to do in order to deploy your smart contract to mainnet is a little bit different than what you're used to on deploy. So normally you would do anchor deploy, right? That's not what we're going to do here. We're going to use the base Solana CLI, which is going to be Solana program deploy target deploy the specific .so file, the binary file that you're going to deploy. This is our smart contract binary. And we're going to do a couple additional flags in order to make sure it gets to production. So remember earlier in this specific part of the bootcamp, we did something with priority fees. So we're going to do the same thing with the CLI, because otherwise we won't be able to actually deploy our smart contract to production. I'm going to add a little bit. You can add your own. What I would recommend is double check what is normal and what is average. So we can go check right now. Actually, we can go to solanacompass.com. You can check this. You can also check some other websites, but you can see what the average priority fee is in Sol. So the average priority fee is it's about 12 or 10,000-ish, with the mean fee being about 80,000. So I'm going to go to make it 80,000. You can do it less, you can do it more, depends on how much you want to wait. And then I'm going to do something called use RPC. So what this is if you're using an RPC that is paired correctly to a actual staked validator that's voting on the network, that makes it more likely for your transactions to make it to the network. You can find more information via the stake weighted QoS article. So I'm going to go pull that up. What is stake weighted QoS? Should be on Solana.com. There's a good guide on Solana.com to what stake weighted QoS is. It's basically just allows you to hit your validator hit your RPC and use stake that's on a actual validator on the network to guarantee your transactions make it to the network. So let us do that. So use RPC. That's what we're going to be doing there. And then I'm going to add a max sign attempts. We might not need these, but what this means is, hey, there's a bunch of transactions that happen with a Solana smart contract deployment. If any of them fail, make sure that you retry them a little bit. So let's go ahead and hit that and let it get started. So you might also want to make sure before you start this, you check your balance. You can check that with Solana balance-um. So I have a little bit of SOL, my local, and you can send yourself money by just typing in Solana address, and that's your address that you send your SOL to. And this is real SOL because we're deploying to a real network. All right, so let's deploy to mainnet. I'm going to go and do Solana program deploy right here with some compute unit price, use RPC with 1,000 max attempts, and we will be back in a moment while it deploys. All right, so we have a program deployed. It took a few retries. You can see it took 6 retries. I put 1,000. I probably could have increased my priority fee to be a little bit higher and would have gone a little bit faster. Just, you can check and try different priority fees. I didn't make myself above the median. You can see the median. It's actually, it looks like I was above the median and I'm above the mean. So I was there, but probably not good enough to be very quick. So I paid a little bit, I got through eventually, and we've deployed it into production. So we can actually go onto the Explorer. So let's go over here, and I'm going to switch to mainnet, and we're going to put in this program ID, and boom, we can see that this is the program account for our smart contract. Now, it doesn't have much information about it. You can see it's missing like security, and doesn't have any domains, but it's here. And you can see my upgrade authorities right here. We have our smart contract on production. So congratulations if you made this far. This is awesome. It didn't cost that much too. So we can actually check. So previously I had, let's see. Previously I had a little over 7 SOL. So let's do Solana balance -um as well. So it cost a little bit, around like 2 SOL to get deployed. So it's a small program or a small smart contract. So good to go. So next up, what we're going to do is we're going to create a verifiable build so that people can view the smart contract code for our smart contract within an Explorer. So they can basically verify, hey, this is the code that I'm interacting with, and this is what I expect it to be. So let's go and do that. So in order to do that, we're going to install something called Solana Verify. And you can do that by just typing in cargo install Solana Verify. So let me clear real quick. So we can do cargo install Solana Verify. If you hit enter, it'll install it. I already have it installed, so I'm not going to do that. And then we're going to use something called the Verifiable Programs API. What this means is we're verifying that the code equals what's on chain, and we're uploading it to, in this case, OtterStack's API. In the future, this might be on chain, but today it's via an API. So we're going to go ahead and run that command. So it's Solana verify, verify from repo, remote, -um, -- program ID. We're going to do the program ID that we have on chain. And so here it is right here. There we go. And then it's going to be our GitHub repo. So let's go grab that GitHub repo real quick. It's right here. I'm going to go ahead and remove all the extra work because we don't need all that. Boom. And we're going to put that right here. And then we have to give the library name. So you can find this library name in Anchor Cargo, it should be Cargo Toml. And you can see here, the Anchor Toml. And you can see here that, let's see. Oh, some programs, Cargo Toml, and its name is voting. So that's under the lib name, so lib voting. So we're going to call this voting. And then finally, we have to give the mount path because our specific repo is not in the root path. Our cargo toml is not in the root path. We have to give it. It's actually in the anchor folder. So we have to do mount path, anchor, and hit enter, and it starts verifying. So this will take just a moment. We will come back very quickly. So while that runs, what we're going to do is we're going to check an actual smart contract that has been verified on chain to showcase what it looks like in an Explorer. So here I am on Solana FM, and we are using the Phoenix program here. You can see that it has a little build verified here. You can go check the verification, and you'll see, oh, here's an actual full end-to-end amount of the code available so that you can see everything here. This is great, and it's great for also people wanting to build their own smart contracts to view them and see what's going on chain. So highly recommend it. Definitely do this before you do anything in production, and let's move on from there. All right, so the next thing that we're going to do is we're going to actually upload our IDL on chain. What this does is it allows other people to pull our IDL down and be able to interact with it or understand how to call your program. This allows you to do things like generate crates to interact with your smart contract, and it makes your smart contract overall more composable across other smart contracts because they can actually interact with it. So you can see right here that the IDL internet thing is right here, is how you do it is right here. So we're going to just run it real quick. So I'm going to go in here, run clear. We're going to cd into my anchor folder, and we're going to do IDL init, and it says to do the target IDL voting JSON, and then my specific program ID, which we have over here. There we go, hit enter. And what this will do is actually upload my IDL onto on chain. So you can actually pull this down as well. You can pull it, let's see if we can pull it down with IDL fetch. So you can fetch the IDL for the specific program ID. So if you do anchor IDL fetch with the specific smart contract ID, so let's do that real quick. It'll fetch it, and there we go. There's our candidate IDL. It's all in the CLI here. We can output it into a specific file, but it's now on chain. So anybody can pull them down and use it to interact with your smart contract. Okay, so for the last thing we're going to do is we're going to upgrade our smart contract deployment to use an upgrade authority that is a multi-sig and not a single authority. So what does that mean? If you look at your actual smart contract, you can see the upgrade authority is this key, the CWT. And I own that key right over here. So let's go grab it real quick. So if we do clear, Solana address, you'll see that my key is CWT. So if someone were to exploit my computer or something and get this key, suddenly they have access to upgrading the smart contract and can upgrade it to something that might cause a vulnerability, an exploit, or something. It can create an attack. So we're going to create what's called a multi-sig and use that to avoid any one key getting attacked. It actually takes multiple signatures to get attacked in order to upgrade my key. So let's go ahead and do that real quick. So we're going to use squads to do that. And we're going to create a squad. All right, so I have, let's make sure that this is right. Okay, cool. So we're going to call this the voting squad. And this is going to be voting for bootcamp. And we're going to use this to create our squad and add our different members. So one of our member addresses will have to be this. The other one is going to be our wallet that we're connected to right here. And we're going to set another confirmation threshold. This confirmation threshold is just for how many confirmations need to approve a transaction. We're going to have it as 1 because it doesn't actually, we're going to have it as 1. What I recommend is you set another one. So let me just set another one real quick. We'll grab my phantom address. There we go. So here we have 3 addresses. One being my backpack address. So let's just make sure that's my backpack address. Yep, E8W. One being my CLI address and one being my phantom address. What I recommend is have it be 3 different CLI addresses, but because I'm just doing this as an example, we'll do that here. And then we have to set our confirmation threshold. So this confirmation threshold, we're going to set it as 2. What this means is that 2 of these addresses or 2 of these key pairs need to provide a signature in order to upgrade the smart contract. So 2 out of 3. We shouldn't just do 1 because that's even worse security. We should have a 2 of 3 or 5 of 8, something that takes a majority with a lot of key pairs. So let's go ahead and hit next. We can see here it's setting, we're going to create the squad. It's got 3 different members. It takes 2 of 3 to upgrade, and this is our fee. That's all right. We can do that. All right, let's confirm it. And we'll ask for confirmation. We're going to approve it. And this should create our multi-sig on chain. There we go. We've created our squad. And so what we're going to do next is we're going to use this to upgrade our authority to this specific squad authority. So let's go and grab that. So what we can do is we want to change our authority to this one. So we're going to go ahead and copy this squad. This is the squad right here, and we're going to update it to this account because we want to make sure that this account is the one that can update our smart contract. All right, so if you go over here to developers, go to programs, we can see here, there's no programs yet. So we're going to add a program. And the name of the program, we'll call this voting app. And we're going to give we're going to give the voting ID. So let me go grab that real quick. Boom. Go back to squads. Put the address in there. All right, let's do next. You need to sign a message in order to use functionality. So we're going to assign it. That way we're adding this program. All right, so we've added the program and it tells us, hey, set the upgrade authority of this new one to our squad. So let's go ahead and run that real quick. So we'll copy it. We're going to go over here into our Visual Studio and we're going to run that command that it gave us. And so that'll upgrade it from the authority of the CWT to this new authority of the squad. All right, now we can go check that on chain real quick. Refresh this right here. We can see now it's no longer CWT, it's that G1Y, which is our squad or our multi-sig. So after the action is done, click Verify Authority. We can click that, and boom, we have our new smart contract. And so this is the smart contract that we want to do in order to, this is the multi-sig that we use to now upgrade our smart contract. I would recommend doing this for not only smart contracts, but also if you do any tokens and you want to have the mint authority still, I would recommend having the mint authority also governed by a multi-sig. So here now, I have this voting app. It is a smart contract, and I want to actually upgrade it. So what we're going to do is we go into here and we click Add Upgrade. Let's call this voting V1. We're going to need a buffer address and buffer refund. This buffer refund, we can just say is our current wallet. So I'm going to go grab that one real quick. We don't have to do the commit link. That's fine. And this is the authority address. So for the buffer address, we actually have to, looking at the logs, do a write buffer. So let's go ahead and do that right in here. So Solana program write buffer, and then we have to do target deploy voting.so. And what this will do is it will actually create a write buffer account for our voting SO, our voting binary. And you can see it's actually trying to run a bunch of things. We don't want to actually do that. So we want to do use RPC, and then with compute priority fees. Let me go ahead and pull that up real quick. With compute unit price. And we're going to do, I'm going to do 150,000 for this one. And max sign attempts 1,000 again. Whoops, should be with compute. With compute unit price. There we go. All right, so I ran into an error. This is fine. It's just we'll have to run it again. That's fine. All right, so it's finished. It took about 5 tries. We now have a buffer ID, so we can go back to the squads that we have, put in that buffer address, and we hit next. And what it says is it's trying to tell us to set the buffer authority to that specific multisig. So let's go ahead and do that. And this will just send a transaction real quick. Boom. Now the authority is that multisig. Verify the authority, and boom, we have a new V1. And so we can hit upgrade, and we can initialize the upgrade. And what this will do is it will require us to sign it on 2 different wallets that are on the multisig. So let's do that on that one. And we can see, boom, we have the upgrade. It's starting to be activated, but we need 2 approvals in order to activate. So I'm going to go ahead and log into my other wallet. So let's go log into that wallet as well. Phantom. I'm going to approve. And once I approve on Phantom, it should be able to initialize and send the upgrade to upgrade my smart contract. So let's confirm. There we go. And so now we have 2 of 2. And we can execute. So I'm going to head and go back to my backpack wallet. And I'm going to execute the upgrade. We're going to go ahead and confirm the transaction. Looks like I'm going to receive the buffer SOL as a refund. And there we go. It's been confirmed, it's executed, and it has been upgraded. So that's how we did smart contract upgrades with squads, with a multi-sig, to keep it very secure, and so that there's not one source of failure with a multi-sig. So it's great. So we've now gone through a number of different things in order to bring your smart contract to production. There are still some more things, like this is not full encompassing, obviously. There's still more things that you can potentially do. Things like you could put your RPC behind like a caching layer, so that when you make the RPC calls, if there's a lot of RPC calls, it caches the responses so that you can get better responses for your users on your UI. We haven't deployed the UI yet. I mean, there's plenty of tutorials on how to deploy UI out there. I'd highly recommend just using one of those tutorials. But we've taught y'all enough to get your smart contract to production and teach you some of the ins and outs to get started. So without further ado, that's everything that we have for today. And now congratulations, you've made your smart contract into production. If you have any questions, feel free to put them on the GitHub repo. And definitely check the GitHub repo if you run into any issues during this. And specifically, the GitHub repo is Developer Bootcamp. You might run into something that, hey, this command didn't work, or something changed. There's always updates going on in the Solana space. So definitely check this repo out as you're building, especially this last project. See if there's any notes on the updates, and then we will see you next time. But yeah, good luck.
Congratulations on making it this far. This was a ton of content to get through and a huge commitment to make. If you've built every project, you should have a pretty good understanding on how to get started building your very own Solana projects. Don't let this be the end of your journey into blockchain development though. There's a ton more out there to dive into. Use your newfound knowledge to join a hackathon, find a local Solana community to join, or if you have what it takes, try creating your own project and start a career within this industry. Make this the beginning of your development on Solana. Congratulations again, and I look forward to seeing you in the Solana developer community.